All right, welcome everybody. Today we're gonna talk about from design to reality, increase your construction efficiency using Helix. My name is Samar. I'm a structural engineer with Helix Steel Engineering Department. So Helix company, Helix is manufactured in Grand Rapids, Michigan, and Helix headquartered here in Ann Arbor, Michigan. Helix have been used now for almost 2 decades throughout the United States and internationally, Mexico, Canada, Australia, and New Zealand. And those are some of our sales team territories. So a few words about myself. I have a bachelor degree in civil, structural engineering, and a master degree in engineering management from Eastern Michigan University. I have a degree in associate credential and more than 7 years experience in structural design and construction, including multi-story structural buildings, helix and rebar. Now I've been saying 7 years for a while now. I think it's like 9 or 10. I'm also a Helix engineering outreach manager. That's why you see me today. I have published papers, including a paper in ASTM, and I'm an active member in ACI. So learning objectives for today, we're gonna be able to describe material properties and performance, explain material corrosion resistance and mixing, select material design and applications, and then we're gonna have Q&A session after. So alternative materials in general, we are all familiar with rebar versus those materials are uniformly distributed throughout the concrete section. So each product is different, their material length, diameter, and deformation. Typically, a test needs to be done, and then based on the performance provided, a design could be performed. So today, we're going to focus on what you will get when you manufacture a product with a twist along its full length. Now, this allows the product to perform in the pre-cracking phase in addition to the post-cracking phase. So this allows the strength required to be met by even lower dosage. And it also allows the product to achieve higher strength. One of the conditions is that you don't need to make any changes in your mix design, no finishing issues, and Helix also obtained an evaluation report, which allows the product to be used in applications beyond temperature shrinkage reinforcement. And we're going to go through the evaluation report a lot because that's what we as a Helix engineering department use, along with outside engineers who want to use their own design. Versus typically the products are based on post-cracking and a large crack width criteria. So what is Helix? Helix physical properties. Helix is 25 millimeter long or 1 inch. Equivalent diameter is 0.5 millimeter or 0.02 inch. Due to the size of it, you have more than 25,000 helix per kg or 11,500 helix per pound. The actual material, the steel wire tensile strength is 1,700 MPa or 246 KSI, which is close enough to what we use in post-tension cables. This allows the product as a high tensile steel product with a twisted profile as shown here. This is Helix as manufactured. Those twists allows the product to bond well to the concrete and makes the product pull out governed by an untwisting resistant rather than just friction. So we're still with what is Helix. Let me show you quickly here. This is a video with a concrete beam, and the machine at the top is attached to one piece of Helix, and the machine gonna try to pull Helix out of the concrete. So the flag at the bottom is actually attached to the same piece from the other side, so you can see the flag is turning as the product untwisting and being pulled out of concrete. Now remember, this performance is for one piece. Typically, you have more than 11,000 pieces per pound. All right. So how does Helix affect concrete behavior? As I mentioned before, I'm originally a rebar designer. So this slide is a key for me to modify my way of thinking in reinforced concrete with Helix. So the drawing on the left shows the conventional section, and the drawing on the right is Helix reinforcement. Conventional section does not behave as a true composite system since concrete must first crack before reinforcement becomes active. On the other hand, Helix perform as a composite system with the concrete, adding a quantity of Helix distributed throughout the concrete section provides multi-directional reinforcement network and create a ductile system. This significantly changes the failure mechanism of concrete from sudden, brittle failure resulting in complete damage to the concrete into ductile system that's more resistant to cracking and localized damage. So let me show you what does that mean in a real-life application. This is a 6-inch panel impact test. So 2 panels have been tested, one with rebar only and one with Helix and a lot of reduced rebar. Both panels have been exposed to 10-pound C4 explosion device at 15-inch stand-up as shown in the video. So the picture on the left shows rebar only panel. You can see the panel shattered under the blast. The panel on the right is Helix hybrid reinforcement, and you can see the panel remain intact due to the ductile composite system of Helix and concrete. So the structural performance, you get a sense of the more material you add into the more Helix you add into the concrete, the more strength you will get. So you'll get increase in flush roll capacity, increase in first strike strength or modulus of rupture of concrete, durability and toughness, and of course a lot of increase in shear strength. So this increase in all of those aspects result in better performing, long-lasting concrete structure. So where can Helix be used? And has been used for many years now. Helix have been used in commercial construction, residential construction, transportation, public infrastructure, whether it's slab and grade, slab and all decks, bearing walls, shear walls, foundations, a lot of continuous footing and pad footing, cast in place walls, transportations, airport, and of course a lot of precast and stormwater retention. Here we have a bridge deck replacement in Missouri, James Madison University Stadium in Virginia, and wind farm with our partner in Australia. So example of our clients, 3M, Volvo, FedEx, Coca-Cola, and much more. This is just an example. All right, so let me show you here. This is a distribution warehouse that Helix have been used in, and this is one of clients' feedback. Using Helix micro rebar increased the daily concrete pull rate by 20%. So let me show you quickly. This is a 1 million square feet facility. All right. too loud for you, let me know, okay? Helix have been used to replace all the mesh and rebar specified. Now I get a lot of questions about finishing with Helix. You can see the whole process here. So Helix is dense material, just like aggregate. So as long as the best practices for finishing with plain concrete has been followed, Helix is gonna sink a little bit, just like aggregate, and there will be a thin layer of cream that will develop at the top, and they're gonna go cover Helix just like aggregate. Now for this project, we kept joint spacing the same, typically based on ACI 360. It's like 2 to 3 times your concrete thickness, but we can provide extended joint spacing if you want to. Actually, I went to the actual job site. It was really interesting to be in. All right, so why even considering Helix? Typically, Helix have been specified to solve our client's pain, whether it's reduce a lot of rebar or eliminate all the rebar. Let's say, for example, if for slab and gray, we typically specify rebar and mesh at the top third of the slab thickness just to get optimized shrinkage and performance. But sometimes it will be challenging to do that, as shown here. That's what Helix have been typically used and have been used to provide time saving, safety for construction crew, cost saving, of course, and while maintaining performance required. So let's look at this quick video about Helix users.
Hi, I'm Bob Deeks with RDC Fine Homes, and we're here in Squamish at the Valkyrie's townhouse site. What is really exciting today is the very first time the construction industry in British Columbia is using the Helix steel additive. And what that has done for us is we've been able to eliminate about 90%, 95% of the rebar in the forming process, and it's actually significantly reduced our cost. So we're very excited at this opportunity, and we're looking to use this system for all our work ongoing.
Helix is actually a micro rebar. It's metal wire that's twisted, and it acts identical to rebar in concrete. It's 245 KSI steel. It's extremely strong. And the nice part about Helix is it adds reinforcement to the concrete even before the concrete wants to crack. The reason is the Helix actually makes the concrete flexible. Higher dosages of Helix, you can actually flex and bend the concrete without a dominant crack forming. That way, in an earthquake environment, the building shaking back and forth, the concrete has a lot more drift capacity before it reaches to a failure mode. A lot of times, if the rebar is in the wrong spot, you've lost more than half of your strength in the wall. Helix solves that problem totally. The reinforcement is from side to side, top to bottom. It's all the same. The wall is as strong as it could possibly be.
My name's Rob. I'm from Quill and Concrete. We're loading this Helix fiber in the loads today. What we're doing is the driver's going out to our transfer wall. The fiber's getting put in the truck. Then we're adding in the water to the load when the truck's under the plant. The truck's then mixing up for 6 minutes just with the water and the fibers. And then once that's complete, we tell the driver to wind it up and we load the concrete into the truck as we usually do. And the driver goes to the rack and slumps it up, and that's it. Then they're good to go.
Hi, I'm Rick.
And we're going to go through some of the mixing instructions later on.
I'm from Summit Concrete. I've been doing concrete for 30 years, and today we're just placed in 35 meters of concrete. Well, that's the thing, like a job like this, normally you'd come up to and there'd be a wire mesh, like a 6-inch grid. And while you're placing, you try and pull it up, and a lot of times it just gets stomped down to you know, where it's ineffective, it's not doing anything. I can see how the strength of it is going to be more beneficial than a wire mesh. Wire mesh is just going to be running in one line, where this is going to be creating all kinds of different, you know, reinforcing. It hasn't affected us in any way of placing. Doesn't seem to be affecting us any way of finishing. So yeah, it's a good product. Really good.
And for all of those projects, we typically involve in the design process of, as a Helix engineering department. And then we have a great sales team who will follow up with any meeting required in between up to the construction process.
The Helix micro rebar replaces the conventional rebar on the wall. Their engineers write an equivalency for that rebar, and it's simply a fine mesh of helical twisted, small little twisted bits of metal that are interspersed throughout the foundation system at about, I think it was 25 pounds per meter. So there is no grid of rebar on this wall, there's just the Helix micro rebar. We have done some conventional rebar around door openings and window openings that are over and above that 16-inch grid, but it was maybe 500 linear feet of rebar that went into the wall. The Helix micro rebar does have a cost to it, but I figure, and this is an estimate, that we probably save 20 to 30% on our rebar install, and a lot of wear and tear on our guys, which is important to me as well. No rusty hands, no rust in your cuts, no infections, no tie wire tearing your skin all up. So guys go home refreshed, they're not as beaten up at the end of the day, and they're able to work that much better the next day, sort of thing.
We used a Helix mix in the concrete here. So typically to tie the rebar in something this big, there's 160 feet of 12-foot high wall, would take 2 days for 2 guys. So that is taken right out of the picture altogether with the Helix mix. It's just a super system, super time saver, and you know, from a business standpoint, that's what it's all about. So I just look forward to keeping going on doing this and not going home tired at night.
All right. You don't want to hear them again. All right, so how does Helix resist corrosion? And that's the typical questions I get each time I do a presentation. As we all discussed, Helix reinforced concrete creates a ductile concrete matrix and has the ability to resist, to carry load prior to concrete cracking. This mitigation of cracks in concrete prevents corrosion altogether, since this limits the availability of moisture, which is essential to sustain the corrosion. Now, if concrete undergo cracking in extensive environment, moisture may enter the concrete and contact with the Helix. As I mentioned before, is zinc, which acts as a sacrificial anode to electrical current. So the zinc coating will corrode first, which protects the rest of the steel from damage. This allows the integrity of the Helix species to remain intact. Now, the last two factors for defense are the small size and the discontinuous nature of Helix, which allows for possible corrosion to occur in extensive environment in some of the pieces without the resulting of spalling of concrete, as shown here, since the volume of steel is not large enough to allow the volume increase necessary to spall concrete. And as we all know, spalling of concrete eliminates the reinforcement protection and is a major cause of corrosion. Helix also undergo DOT corrosion resistant test, and typically the tests performed for I think 30 days. Helix have been tested for 90 days and with a great results. So some mixing instructions. Let me show you here. We have a quick video on mixing with Helix. Helix could be used whether it's like a ready mix plant or side batching. Let me show you here. This is for ready mix. Just in general, Helix will be shipped in 45-pound boxes. So all they need to do is just dump the boxes in and then add first the water. It's like anything more than 50% of the batch water first. Mix for 45 seconds and then go back to normal manner of mixing.
Hi everyone, my name's Luke Pinkerton. I'm with Helix Steel. We're here at Doane Companies today in Ann Arbor, Michigan. We're going to be demonstrating the dosing procedure for Helix Steel in ready-mix trucks today. I think you'll find this very informative. You'll also see just how easy it is to add Helix to a ready-mix truck and get a consistent mix each time.
Helix, they need to go to a full charging speed under the ship.
Alright, hey, I'm Richard Harden, dispatcher here at Doane Concrete, running a Integra dispatch command batch system. What we're going to do here is throw a little bit of water in this truck. I'm going to let the truck mix up about 45 seconds or so and then proceed with the batch. So I'm about to throw in about 70% or so of the head water and let them mix up.
So anything more than 50% would be fine. I'll make sure to distribute Helix throughout the truck. For side batching, we recommend using a 2x2 mesh or Helix dozer machine, depending on how big is your project. All you're gonna do is making sure Helix goes into the truck in a controlled manner and breaks up any clumps. So those are some general instructions about Helix. All right, concrete mix design. As I mentioned before, Helix doesn't require any change in mix design. We do recommend a minimum of a slump of 4 inches, typical mix. However, we can run mix analysis if we can get the mixing proportion for your mix, along with sieve analysis. Then we can run quick concrete mix analysis with Helix dosage, but typically doesn't require any change in mix design. So let's move on to the technical side. Is Helix design code compliant? As we all know, the IBC, International Building Code, IRC, International Residential Code, along with any concrete code, design codes, whether it's ACI or British or Canadian code or any international codes. As I mentioned, we deal a lot with our international partners. So all of those codes have alternative design allowance. So those codes allow the use of Helix as an alternative design. So it has undergone a detailed review process and obtained an evaluation report. So the evaluation report approves the use of Helix in applications beyond temperature shrinkage, and as long as the design has been performed in accordance with the evaluation report. And we're going to go through the evaluation report in the upcoming slides. So the construction industry has used evaluation report for many decades now. So here's the first page of the evaluation report. So it's actually ISO Guide 65 evaluation report. It provides assurance based on public review process. All the testing have been performed in an ISO accredited laboratory. Within the evaluation report, there are detailed design procedures contained in the report and also includes several work examples, and we're going to go through those. Also included design instructions, restrictions, examples, and QC requirements. So the main goal of the evaluation report is to assure you that the design met the intent of the code and the design is going to meet the structural capacity required for your structure. So liability, I get a lot of questions about that. So as long as the design of Helix has been performed in accordance with the evaluation report, then that's all we need to submit to design approval. So I'm going to show you in the upcoming slides, but we typically refer the evaluation report for each section of Helix design. So as long as the design procedure following the evaluation report section as shown here, let's say evaluation report section 4.1, 4.2, 4.3, then this analysis along with the evaluation report will be submitted to get alternative design material approval. So Helix design methodology development. So at first we need to perform testing. So it has been performed in ISO accredited laboratory. And then we need to establish resistance fraction and variation, force and distribution. And then we're going to have design classes, which is similar to what we do with rebar. So if you need temperature and shrinkage reinforcement, you're going to specify light rebar or even light mesh, let's say W1.4. If a structural performance required, then the rebar going to increase. So the same thing here, the higher strength you need, the higher dosage will be specified. And then we're going to have analysis and design model, and all of those three factors combined going to establish Helix LRFD design method. So testing, Helix have been tested under ASTME 111 tensile test. The machine plot the tensile stress versus strain, and that's what using analysis. So how can we design with Helix? As I mentioned before, the Helix dosage will vary based on the performance required. So within the evaluation report, there are 4 classes for design. Class A for temperature and shrinkage reinforcement, Class B for supported structures, Class C for all other structures that don't meet Class A or B. And then, so we do a lot of custom design. So based on the size of the section, the reinforcement specified, or the capacity required, then those classes gonna vary based on design required. And there's also class CS, which is mainly for warehouses with high racking loads or high wheel loads. So this procedure follows a CI 360 yield line analysis. All right, so Helix design class selection flowchart. Just to make it easier for us or outside engineer who want to do their own design, we provide a flowchart in the evaluation report. So let's say we're going to start from the start, and then the structure is soil supported. Let's say it's on grade. If it's yes, we're going to move to the left to shrink it, whether the reinforcement temperature shrinkage or structural performance. Let's say it is for temperature shrinkage. Then it's yes, then we need to use class A. If no, we need to do additional checking and then use class B instead. So as I mentioned before, within the evaluation report, there are design examples. I'm not sure if you can see it, but here are they. So it provides few steps to determine Helix dosage using some of the tables included in the evaluation report. So step one will be to determine the class design. As we mentioned before, it's based on what type of strength you need or what type of performance you need. Step two will be compute the area of steel required at the center of the tension of the section. And then step three will be using one of the tables in the evaluation report, which is table 1, which allows to find the nearest area of steel in column 1 and read the required number of helix for the appropriate compressive strength. Now, within the evaluation report, there are tables for 3,000, 4,000, 5,000. Just because we were limited with the space, but I'm going to show you a design program here that will perform Helix design based on any compressive strength you use in your design. Step 4 will be divide the number of required by the area and tension, and then we're going to go to table 2, find the nearest number of helix per unit area in column 1, and then read the required helix dosage for the appropriate class and compressive strength. So we'll transfer from tension force required into how many helix required per section, and then transfer that into pound per cubic yard. So here are the main 4 steps for calculations. So the design of helix is done similar to the design of rebar, only at a smaller scale. So first, we needed to determine the required tensile resistance. This analysis will result in determining the required area of steel and tension. Now, if we get structural drawings, then we actually back calculate the bending moment capacity based on thickness of section, compressive strength, rebar size, spacing, and of course concrete cover. So we back calculate the bending moment capacity required, and then we go from there. If we have access to the engineer and he or she is still in the analysis process, then we can get the bending moment capacity and just go from there. Or if we can get some loads specified, then we can run ground up analysis for it. The second step will be determine the appropriate helix design class to be used for the section being designed. And then, of course, we need to determine the number of helix required per unit area to carry the calculated tension using the capacity of individual helix. And then the last step will be determine the helix rebar dosage required using the number of helix per unit area. So here we have the free body diagram for helix design. Helix is distributed throughout the section, and the fibers are engaged at low strain levels. Therefore, a uniform stress is developed over the entire tension zone, and this uniform stress can be modeled as a single piece of rebar acting at the center of the tension zone, as shown in the free body diagram here. Then, of course, we need to determine the neutral axis depth of helix, which is calculated based on the moment capacity of the conventional reinforcement section. Now, sometimes we do have, we can provide hybrid design, but typically our engineers or our clients ask us to provide full replacement of rebar. And then after determining that, the remaining terms shown in the free body diagram are calculated as shown here. Then, efficacious area of steel required at the center of the tension zone can be calculated based on the changes in location of the centroid of helix tension zone from the original rebar. So, and then take that number and determine the required number of helixes calculated using the following formula. Now, this is based on the testing for helix, and those constant are helix model constant, helix concrete strength progression term, helix bond ratio, and helix linear term. And then use that number. The required number of helix per unit area is calculated by dividing the required number of helix by the tension zone area, and that will give you helix per inch square. And then we still need to determine the helix resistance factor by analysis of multiple source of potential variability. Those variables include the helix dosage rate computation product, tension testing, any variability in design. So we're going to compute the exact dosage required based on capacity, but then by applying a resistance factor, the dosage will be increased, and that's the dosage we're going to recommend using. That's the final dosage to be used. So whether it's us as Helix engineering department or outside engineer can do each of those tasks by doing hand calc. But I know we are all busy. So what we've done, we actually create a design program for Helix. Let me show you quickly here. So here is Helix, what we call a side-by-side. So this is the customer info. That's what we use when we send you a design, the project info, address, and any notes we have. And then the input page, like I mentioned before, typically get structural drawings. So based on the thickness, code used, concrete compressive specified. So whatever concrete compressive strength you use in your original design, that's what we're gonna use with Helix. And then rebar size, rebar spacing, and then of course where the rebar placed, whether it's 2 layers or 1 layer, and then yield strength to the 60,000. Calculate the bending moment capacity specified, and then program gonna run the analysis that we just discussed and Helix you need. Now the program run also some checks. Let's say if the class is wrong, the reinforcement is higher than the required for temperature shrinkage, then the program gonna give a warning that the class need to be increased. And then the printout is the last page, is the pages we send out and we use to get for approval. So there's the first page, and then that's why we call it side-by-side. So you have a side where you have rebar and side where you have Helix design. And then after that, there will be a 12 or 10 pages of calculations that give a step-by-step design along with referring to the evaluation report for each individual section. So here's the back computation, and then here's Helix free body diagram, and then those are all the computation along with referring to the evaluation report. So this is the main design program that we use internally here as Helix engineering department, but we also give it to outside engineers who want to run their own analysis or even do some checks with it. All you need to do if you are interested, let me know. I can send you a NDA So if you could sign it, send it back to me, then we're going to send you a link. You can download the program, and then you have access to it. And the program will be our secret. So if you're interested, let me know. And again, if you have any questions about it, you can always call us. We are available all the time. All right, so let's move on quickly here on in like a few applications in specific. So for slab and grade, Helix replaces the main field reinforcement. Any additional local reinforcement like re-entry corners, penetrations, other stress concentration reinforcement, and construction joints need to remain. Here are some of the example projects. Helix have been used in International Airport in Mexico. And the client we have designed and developed over 4.5 million square meter of Helix steel concrete with 100% customer satisfaction. So the original design was number 3 at 14 inches, replaced with 10 pound per cubic yard of Helix. Here we have ABB, high voltage facility in North Carolina. The original rebar was 2 layers of number 5 at 12 and have been replaced with 27 pound per cubic yard of Helix. Now for slab and grading specific, how to design Helix slab and grade based on loads. So if you have, let's say, a warehouse with any wheel load, uniform distributed load, or a racking load, you can send it to us, and we're going to perform a ground-up design along with the soil condition, mainly the subgrade modules. Thickness reduction example. So this is an aggregate facility, and the original design was 12-inch plain concrete, and it only lasted 3 years. And after that, they needed to replace it. So the client came to us, and we went in with 6-inch concrete pavement with 30 pound per cubic yard of Helix. Now, I'm not saying that's what we typically do, just cut the thickness in half, but that was one of our clients' requests. And we used 30 pound due to a lot of fatigue loading on it. So this slab is performing now for 8 years with great conditions so far. The finished face of concrete, I got a lot of questions about it. Like I mentioned before, the Helix is dense material, so by applying the best practices for finishing, product gonna sink a little bit, and then there will be a thin layer of cream gonna cover Helix just like aggregate. And mixing, finishing procedure. All right, yeah, so those are, let me show you quickly here. We have a video just to make it easier. Let me show you. Maybe not. Okay. So here's it. Well, this is the speed up. At some point, the gentleman again is on the surface, and you can see the finished surface. Yeah, so the concrete will be smooth just like you have it with without Helix. All right, here are closer look at the surface. rebar versus Helix sun recycling. Yeah, so Helix have been used in sun recycling facility. I think this is almost the last video. Let me show you quickly here. This is a sun recycling facility, and the gentleman is gonna walk into two sections, one with rebar and one with Helix, and he's gonna compare them. Now we are not sure if he's the owner or the project manager.
Recycling Center, Pompano Beach. This is the slab that is without Helix. This is an old slab that was poured with no Helix reinforcement. As you can see, the corners are all broken up, and the whole slab altogether is just all broken up, just horribly broken up throughout the whole crack section, all the way back here. And then this is where we come on, and we've got the Helix reinforced slab that, as you can see, has been scraped and bruised and battered with many thousands of tons of scrap metal and equipment poured over it. But look at the corners again. If we look at the corners, you don't get that cracking coming off the corners like you do on the slab that is poured without Helix. Let's come over here. Here, it's very well beaten up, very well scraped. And again, no cracking whatsoever throughout any of these panels.
All right.
Sun.
So footings, Helix have been used a lot in footings, whether it's continuous footing or pad footings, or any customized footings you have. So typically when we get structural drawings, if the generally specified longitudinal reinforcement, then we're gonna run equivalent direct tension analysis, since that's the ultimate use of longitudinal reinforcement. If there are transfer reinforcements specified, then we're going to run flexural analysis. For pad footings, flexural analysis replace reinforcement each way. So Helix replaces the main field reinforcement. Any dowels need to remain. So here's one of the projects where Helix have been used. This is a sound storage facility in Australia. They had, I believe, 2 layers. Well, they have different size of rebar. So N12 at 400 have been replaced with 13 kgs per cubic meter of Helix along with the entire site. Composite slab and metal decks. Helix have been used a lot in those. Minimum dosage is 6.7 pounds per cubic yard. So for composite metal deck, you have the steel deck gonna perform as the tension reinforcement, and then the concrete will be in compression. So that's how Helix replace their mesh in it. Real life applications. This is MSU faculty in Michigan. W3 replaced with 9 pounds per cubic yard. And here we have Helen Divers Hospital. The original mesh was W2.5 and replaced with 8 pounds per cubic yard of Helix. Now walls. Helix have been used a lot in above and below grade walls. So just like what we do with rebar, the analysis, we're going to target the main field reinforcement or main capacity required. And then anytime we have additional rocker reinforcement, because as you all know, each time you change the concrete geometry, you get stress concentration. So Helix is going to replace the main field reinforcement and any additional rocker reinforcement specified on the drawing, such as rebar around doors, windows, penetrations, dowels, connecting walls, steel bars, or any additional local reinforcement need to remain. So there are some of examples. This is the Hilton Garden Hotel. 18 pounds per cubic yard of Helix have been used, and here we have a Waterloo tower. It was like 25 for 24-story building, and those are shear walls, so they went from 2 layers of rebar into 1 layer on center with Helix dosage. Here we have the villages in Florida. 10 pounds per cubic yard of Helix have been used to meet FEMA spec for tornado and hurricane, and this project have been going on for many years, so I think that's 5 years or so. So over 6.5 million square feet and 122,000 cubic yards of concrete has been supported with Helix steel, which this equates to 1.2 million pounds of Helix. Let me show you here. This is just a quick test. So the wall was allowed to occur for 7 days, and then backfill was placed against the wall. The backfill is important because 12,000 pound loader was run parallel and close to the wall to a dynamic and static compressive loads. Ours was placed on the backfill near the wall, and water was allowed to saturate the backfill for 7 days. Not only did the backfill become saturated, the soil at any point within 15 feet of the wall was saturated to add about to a depth of about 8 inches, and no visible change occurred in the wall. It's not like ASTM approved test, but it's like abuse test for the wall. At some point, they're gonna throw some aggregate. Yeah. All right. So how can I get Helix design for my project? You can have access to the design program by signing NDA, and you can on analysis if you want to. We also offer free engineering service to support our project. So if you can, you are still in the analysis process, you could share with run analysis for you, and we provide 10 or 12 step-by-step calculations along with referring to the evaluation report for each section. So to specify Helix design, this is some of the language that engineers have been using. Helix manufacturer, and then material, and then drawings call out. So just like what we have with rebar, typically in Helix project, it's not specified in solid grade only. It's specified in solid grade, continuous footings, pad footings, walls, on deck. So any grade beams, so any customized design we do. So what engineers typically do is just they actually have a note on individual section and specify how much dosage required for that specific section. Now we typically make Helix dosage uniform throughout like individual application. Let's say if we are doing pad footings, there are typically long tables with different thicknesses and different rebar specified. So we're gonna run analysis for each one of those pad footings, and they recommend using the highest dosage, and then they can just put the entire thing with one dosage. That's all I have for you today, and I welcome any questions you have. We have a question here. What is the side-by-side access limited? It's not really limited. So if you are interested, let me know, and I can send you. Yeah, I can send you Helix NDA, sign it, and then we're gonna just do it. Yeah, we are available all the time to answer any questions. Evaluation report examples. Yeah, so I'm not sure if you can see it or not, but here are the examples. Now, you can do that, it's up to you, but we are trying to make everybody's life easier by creating that program. So if you, you can run hand calc if you want, but I would recommend just have access to the side-by-side. Wall foundation walls. So wall designs will be customized typically. So if you're talking about basement walls, if you can give us your soil lateral load along with wall height, backfall height, then you can run ground up design and see how much dosage you need. Could vary. Yeah, so Helix dosage will vary based on the capacity required. Now, there are some checks we need to perform within the evaluation report. So those checks need to perform first to determine which class we need to use for your wall, and then equivalent capacity will be performed. Soil load less than. You don't mean soil, you mean soil condition? Yeah, so the subgrade modulus, I've seen typically 100, 150. Now, if you have a value lower than that, let us know, and then, well, we need to know to consider it in design. Yeah. Grade beams, yeah. We've done a lot of grade beams, so if you have a spec in mind, let us know, and well, we need to have access to it. So send us the section you have, dimension, compressive strength, rebar specified. We typically, for longitudinal reinforcement, we're gonna perform flexural analysis, but then for ties, we're gonna perform shear analysis and see if we can take it out. But we're typically able to take it out just because grade beams have a really reasonable size. So we have enough pieces in the section so we can take out more rebar. Slab and metal deck. Yeah, so the dosage will vary based on what type of reinforcement you currently have. Yeah, all we need is your slab and metal deck thickness. Well, mainly the concrete thickness, and then the mesh specified. Then we're going to perform equivalent analysis for it. We typically have direct tension check at the top because that's the ultimate use of it. Do you need to certify users? No, not really. So as long as they follow those instructions, then they can use Helix. We typically send those along with Helix when we actually ship Helix, so they will have access to it. We also have some videos that we're going to show them how to do it, but it's not necessarily a full license stuff. Can I get projects on? Yeah, I can get you a list of projects on your state. Now send me which state you are in, and I can send you a list of projects. Okay. All right. I don't see a lot of questions. Well, any more questions, I guess? All right. So if you, again, for the ladies and gentlemen who wants access to the design program, send me an email. I can send you a link, and then we can go from there. If you have more questions, let me know. We can do customized lunch and learn for you and your firm at your convenience. If you're ready to use Helix, which is great, just send us a project or a spec. You want to see what Helix can do for you, and we can work on it for you. Okay? All right, that's all I have for you today, and have a good one.